And we will go on to Kevin. Kevin Cannon. Are you on? Are you on? Sounds like you are. There you are. Take it away.
Next slide. Yep, next slide. Okay, so I want to address 4 points here, 4 slides. So the first point is that an exploration campaign or strategy mirrors the nature of the resource. And I'd contend that we don't know enough about the nature of lunar ice to actually decide what that exploration campaign will look like. And so a first order question is to figure out what we actually have. So for example, on the left here, if we have a hard rock deposit, some of these ores like platinum or gold on Earth, then we really do need to go out and drill, dozens, hundreds of drill holes and use these advanced geostatistical techniques, kriging, simulations, etc. And we only do that because we absolutely have to. It's very expensive to do this. And the reason we have to is because we've depleted all of the ores over the last few thousand years. And what's left is so dispersed and diffuse that this is the only way we can find economic deposits. But what if the lunar ice looks something more like what we have in the middle, a coal seam or a phosphate deposit or a gravel deposit? In that case, you wouldn't use those same exploration techniques. You might use something like the trenching that Laszlo talked about, right? Or on the right here, what if we have a situation like the gold rush in California in 1849? If you'd showed up and said, okay, here's our 2-year exploration campaign, this is what we're going to do to find all the gold, everyone around you would have said, well, screw that. We're just going to jump down into the riverbeds and start pulling out nuggets. And within that 2 years, all of the low-hanging fruit would already be gone. So we need to know what the nature is of the lunar ice. Which of these do we have on our hands? Next slide. If we do have a bonanza, if there's a lot of ice everywhere, we can be pretty certain with the data we already have that it's not right at the surface or close to the surface. We know what it looks like when we do have that situation because we can look at the polar deposits of Mercury. Mercury's cold traps are filled to the brim with ice. You can see it in the visible imagery. It lights up like a Christmas tree in the radar data, and that's definitely not what we have at the lunar surface. So people have used advanced processing techniques in the bottom right here. You really can't see any visible evidence for the ice. It does show up in some of the spectral data sets, but there's no geomorphology consistent with ice. We can't really see the deposits. The radar is pretty ambiguous. So if there is a lot of ice at the lunar poles, it's probably buried at depth. Next slide. So that brings me to the next point, and that is that microns is not deep enough, and I would contend that neither is 1 meter. So for all of these techniques, we're going to talk about the reflectance spectroscopy, thermal radar, etc. One of the most important questions to ask is what depth can they actually penetrate to beneath the surface? If we're talking about things like LAMP, LOLA, M cubed, those are only seeing microns beneath the surface. They cannot tell the difference between a transient ephemeral frost that's moving around in recent geologic time versus an actual deep deposit of ice. And, we're all cheering for Viper, but I'd say that 1 meter is probably not deep enough going forward. It's not just my models, but other people, for example, Andrew Wilkowski recently. When we look at the deposition side, other people are also coming up with these answers of, tens to hundreds of meters in terms of the stratigraphies. And from Emily Costello's work, she has suggested that the upper meter, maybe several meters, have probably been gardened away and eroded quite strongly over the last few billions of years. There may not be much ice at all in that upper meter, and that's consistent with a lot of the remote sensing data sets. So next slide. So the final point here, the first steps of an exploration campaign should be to figure out what we actually have. And these are some ideas of how to do that, go to multiple locations, actually get into these large old cold traps that we've talked about, go greater than 1 meter depth, focus on continuous 3-dimensional measurements, and don't assume that we have to go out and drill hundreds of drill holes and try and use these geostatistical techniques. Thank you.